All right, good afternoon, everybody, and welcome to the Phantom session. SP9666 had a little bit of a confusion with the conference folks for getting it set up, but we have it here this afternoon. I am not Jan Jackman from Sweden. Jan Jackman is actually the Vice President of Cloud Services. They originally had this scheduled for 10:30 this morning, and some of you may have been looking for that at this time, and she unfortunately wasn't able to be here this afternoon to present. So my name is Bruce Oddie, and I'm with IBM's Corporate Cloud Marketing Team, and I'm going to be filling in for Jan. And with me I have Pratik Gupta, who's an IBM Distinguished Engineer, and as many of you might be familiar with IBM's process, that's quite an accomplishment to get to the DE level. And his focus and specialization is in the virtualization management as well as in the cloud computing, and he comes to us from IBM Software Group. And he and I will be jointly presenting together. And so without further ado, I'm going to move into our presentation on virtualization management and cloud computing. Many of you, hopefully all of you, at some point in time have seen ads or something where IBM talks about Smarter Planet. And if you walk out of anything of this session today, at least you'll have an understanding of what we mean by Smarter Planet, why that came along so important. It was actually introduced by Sam from a talking points standpoint to the European Union in Turkey, followed then by a meeting with the United Nations in November, and then followed by a meeting with the U.S. Congress as well as with the President and talking about it. And the intent of Smarter Planet is it's not an IBM marketing thing, it's not an IBM thing. It's the fact that the world that you and I live in today relative to technology and delivering technology to business and end users has reached this crossroads point. And the crossroads point is that we today have the ability to instrument virtually anything and digitally connect it to the internet. We have the ability to see nearly 6 billion people around the planet connected to the internet in some way, shape, or form, and in many cases, multiple ways that are happening. And we're now at a point where we can actually use the technology that we have, not just simply to do kind of back office operations and some normal compute type of stuff. We have the ability to take the technology to actually drive innovation, to learn new things about our planet and things that are discovering. And examples of that are, for example, with the Intelligent Oil Field Technologies, working in collaboration with a major oil company out of the Nordics. And in their particular case, they have a lot of offshore platforms where platforms themselves are very sophisticated production facilities. Highly computerized, they're monitoring everything that they're pumping, continuously reporting everything that they're pumping. Something that I didn't know until I started moving into some of the cloud computing and understanding it was that little factoids. So for example, in the oil industry, even yet today, less than 40% of what is pumped out of the ground is actually usable as crude oil. The balance is sludge and waste gas and water and other things that they have to dispose of. And that affects productivity. And in this particular case, with their offshore drilling, the company we were working with was somewhere above 50%. They wouldn't tell us exactly where. They were somewhere above 50% as to what they were pumping out being usable crude on average. But they really wanted to improve it to a 75% target, and could we help them do that? So working with IBM Research, we studied all the data that they had from what they had been putting and pulling up out of the ground, and what we discovered, and this was about 4 years ago, was that the oil fields deep underneath the Earth's crust ebb and flow just like the oceans. And that we can actually now monitor oil fields so that the oil pumps themselves can maximize productivity. They can pump only when the richest amount of crude is directly below that pump, that particular oil, that particular drill hole. And in this particular case with that Nordic company, they were able to improve their productivity, in other words, the percentage of usable crude over a 10-month period by over 25%. They wouldn't tell us again if they ever made their actual target, but huge productivity improvements. The other side that they hadn't really counted on was that they were able to drive out operating costs across their oil derricks by nearly 30%. They virtually eliminated overtime. They virtually eliminated any needed emergency maintenance projects because they now were able to map oil field by oil field by monitoring all the derricks and all the wells over a single field area. And they were able to know on a predictive basis when they would have to go perform maintenance, when to turn it off and not have it pumping, because what it's going to be getting was more water and sludge than oil. So they became much more intelligent about what they were doing. This has led then to a company out of France that I had a chance to meet with in Boulder that is actually developing now nanotechnology, little nanobites that they're going to drop down the oil wells, millions of these nanobites that will then go in and map the entire field, so they know the size of the entire field, and on real-time basis provide current real-time information of where exactly the crude is. So we're going from knowing the data by monitoring what we're pumping out to actually having technology embedded deep under the earth providing us information. So we're getting smarter about how we're managing and handling that particular business. And it cuts across supply chains, it cuts across our energy grids, where with our energy grids, right, the utility company is basically a shotgun approach, right? We generate a whole bunch of power and we blast it across our lines. And more of the energy companies are now putting in smart grids where they're actually monitoring usage, and they're able to then provide the electricity that is needed to match the usage. And in so doing, Energie Württemberg, for example, out of Germany, basically said that they were able to move out anywhere from 3 to 5 years plans that they had for building new power plants and requirements. In the case of an energy company, a utility company located on the East Coast, they were able to scrap 3 plants that they had planned on building over the next 10 years because their existing plants were able to manage the capacity and needs based on being smart about how they were delivering them. So that's what the Smarter Planet's about. It's about how do we leverage technology to be able to do things smarter, better, and faster. So this is great. It's driving a whole new economic climate that we're experiencing on a global scale, which is good and bad, right? I mean, we're seeing things happen much more rapidly than ever before as it relates to the good side and the bad side from an economic standpoint. It's also driving huge amounts of complexity because somewhere, as my boss David Parker said in a video interview, clouds are wonderful, but somewhere, someplace, there's a data center at the heart of that cloud, and somebody's got to manage it, right? So for that person managing it, it's getting much more complex. It's getting much tougher to be able to manage that. They have to be able to do more with less because budgets are being cut, not being increased. They're in the job of reducing risk. Make that experience, end user experience for the business as risk-free as possible. Yet at the same time, threats are ever increasing. Externally for sure, but even much more so on an internal basis. You have to deliver higher quality service, but you have to do so much faster. And so a lot of organizations are turning to, hey, is cloud computing a way that we might be able to enable that? So I want to set a definitional line for cloud computing from an IBM perspective. Cloud computing is not a technology. Cloud computing is not something you buy. Cloud computing is a delivery model, or what I like to call a delivery philosophy that says you want to put in the power of the end user the ability to be in control of the environment they're accessing and how and why and where. It's what we call the consumerization of IT services. It grew up out of consumer internet-based services. When you're booking your travel online through a website like Hotwire or TrueTravelocity.com, you're using cloud, right? Through that particular organization's website, you're then interacting with a networked link that was put together for the travel agents. You're now interacting directly, not an intermediary travel agent. And through that system, you're interacting with the systems of the individual companies that you're selecting. Such that once you pick that airline, you can go in and pick the seat. When you pick the hotel, as I did recently with Hilton, right, I can go right in and select the room I want. Which means I'm interfacing right with that individual property's reservation system to know which rooms might be available for me to choose from, right? So it grows as big as I need. Once I'm done, I give up the resources and they go to someone else to use. The same thing with the banking. The ability to do banking today, not only just online, but through your intelligent phones. Last time I got a call from the bank, they were calling me to report to me, gee, we've seen some activity that looks a little odd. Did you charge $1,800 at a sporting goods store in Australia? And I said, no, I've not been to Australia recently, so, but they're watching and monitoring on my behalf. But my experience with it has all been through my BlackBerry, where I transfer funds, I make deposits, I pay bills, I do all of that sort of stuff. That's me using a cloud, the consumer cloud, if you will, that they're presenting. So why can't we do the same thing for business services? And that's where cloud computing comes about. It says, rather than looking at projects on a siloed type of basis, which even with virtualization and virtualization management, I was just talking with a customer this last week that has like 65% of their environment is very virtualized. But they're still, as far as the business services that they're looking at them in silos. And how are we delivering that silo stack? And when we're talking about cloud computing, we're talking about sharing resources across the entire set of silos in support of those silos themselves, or what classically could be called service-oriented architecture. Because service-oriented architecture, whether organizations have implemented a formal SOA process, if you as an IT organization are in the business of delivering services to the business, then you're service-focused. You make the choice as to whether you want to build that on a foundational architecture so you can do it repeatedly in a consistent manner or not. That's up to you. But that's what service-oriented architecture is. It's just an architecture so you can do that repeatable. And it really does become at the foundation of cloud computing, because cloud computing is how do I deliver services to where even the end user is in charge. And that also then presents a lot of challenges and issues to service management. Change configurations, provisioning, deprovisioning, monitoring. How do I handle the security? How do I handle the resiliency? All those things come into play. So last year we conducted a study, right? From an IBM perspective, we contracted a third party to conduct a study. We interviewed right at about 1,100 customers in 8 countries around the world. And this was a combination of IT managers, CIOs, and business leaders. And we asked them a whole lot of questions about cloud, what their understanding of it was, that sort of thing. And these were some of the findings that came out of that. Cited as 77% and 72% of them responding, the 2 top reasons for interest in cloud were cost takeout and faster time to value. Those were the motivations. I need to be more agile. I need to be able to deal with the complexity and the rapidly changing environment around me quicker. And I need to do so at a lower cost. However, at the same time, security and control were a top concern. And even today, that's still the case. Workloads and patterns are emerging as to what you do around cloud, right? And the fact that you don't just take the entire infrastructure and make it cloud. It becomes cloud based upon what the business says, yes, this is appropriate for enabling for the end user. Right? So you look at it from what we call a workloads focus. We're also seeing collaboration and analytics meta patterns are starting to generate, and then industries with greater cost pressures seem to be those that are leading in cloud adoption. In the U.S., the single largest industry adopting cloud today is the U.S. federal government. From an adoption rate standpoint, and that's from IDC and Gartner both. But while those are the reasons for it, the actual driving motivations have been different. In the case of the Bank of Tokyo Mitsubishi, it was all about how can we control risk management compliance, and in their case, what if there was another outbreak of like the H1N1 virus and we have a bunch of employees having to stay home? How do we make it accessible for them to still get their work done? And that was their reason for looking at cloud. For Panasonic was how do we improve productivity as we pull 18 different divisions together under one single brand, one single email system, one single instant messaging system. How do we pull those together? And it was around employee productivity. In fact, they had put out a bid for building out their own infrastructure before they decided to go to the cloud road. In PayPal, it was how to create an ecosystem so that other third-party ISVs could use their software solutions and test it. And with the U.S. Air Force, it was all about analytics and security. Now, when it comes to cloud deployments themselves, right, there are varying gradations of cloud. On the far left of the screen, you'll see private cloud, which is building out a private cloud behind my firewall. I build it. It's all mine. It's myself. I can run it, drive it. On the far right is the public cloud services with third parties. And there are varying gradations of public cloud. I mean, public cloud, you can have access where it's totally free. Public cloud, you can have access where you have to register to be able to use it. Public cloud access could be where you have to swipe a credit card, so a little bit more security if you have to swipe the credit card and pay for it. Or it could be even what we call or have coined like a click-to-contract type of thing, where you have to have a known relationship with the provider to be able to access those services from it. But all those are varying forms of public cloud. And in between those two, you have shared cloud services, where you have groups coming together and forming cloud that they're going to be sharing. Collaborations of insurance companies has occurred, collaborations across pharmaceutical companies, healthcare companies, banks. A number of industries have put together shared cloud services. Hosted private cloud means, it's a cloud for me, it's private to me, but it's being hosted and managed by a third party, but it's still the private cloud side. And then the managed private cloud is usually on my premises, but I've got a third party managing it. So you have those gradations of cloud computing in between. Why are they still cloud? Because of the end user delivery model focus, right? You got to keep that in mind. From our viewpoint, cloud means you're putting the end user in charge, and you're enabling the end user to be the boss, no matter whether it's an infrastructure as a service or as a business process as a service. They're the ones that have the controls. And then, as you saw on the bottom of that, the hybrid cloud. Well, IDC agrees with the perspective that hybrid cloud is, in fact, probably, for the next 2 to 6 years, the direction that most organizations are going to go from a comfort standpoint. Cost effectiveness, leveraging their own resources, as well as the security and risk issues associated. That's also then why IBM acquired Cast Iron Systems in May of this year. Was the sole purpose of that integration point between public and private clouds. Because we agree that hybrid is the model that most are going to be adopting. At the same time, they're also going to be taking public cloud services and needing to integrate it with their traditional requirements that they do. And that also then helps us from the service management standpoint in driving that. So when we talk about workload driven, what we're talking about then is kind of those business functional workloads around analytics or around collaboration or engineering design, for example, right? That would be a business function workload where you might pull together a collaboration cloud and a desktop cloud and a storage cloud to be able to provide this engineering design cloud where, like Taiwan Semiconductor Manufacturing Company, you have 5 plants located around the world, and the sun never sets on a development project. They're all working on the exact same files at the same time, collaborating together from a development standpoint. And the VP of engineering there said they've been able to trim anywhere from 2 to 3 weeks off of development time for their projects. It's been huge for them to do that. On the flip side, they also didn't have to replicate a very expensive design program that they had installed in Taiwan at their other sites. Everybody accesses that one design program at that one location through their cloud. So it's testing for that ability to be able to make the end user in charge and drive it. And those are the types of things that we're looking for relative to standardization. How standardized can I make it? Examining it for risk. What kind of data, what kind of information is it going to be? This is also what drives as to whether it would be public or private. As well as then, exploring new workloads where you're leveraging third-party resources and not having to put out the capital, but now you can afford to run those types of analytics and put them in place. In fact, Ingrain Rocks and a couple of other companies have literally built their businesses on the back of IBM Cloud Infrastructure Services for running analytics. In the case of Ingrain Rocks, they do heavy analytics for the oil and gas industry before they're going into particular sites. And they basically then, using cloud, get access to the compute resources every time they have a project. They use our computers. It's all of their applications, all of their data using our computers. They access them, use them, pay for what they use, package that up as part of the contract, deliver, and then turn it off. So they're not having to buy any compute resources. In their case, they're growing at a rate of over 40% per year without having to expend capital for the compute resources for the analytics that they're driving. So some workloads, as you think about it, then it's pretty common sense. Some workloads will be ready for cloud. Some workloads may not be ready for cloud because of data sensitivity, because of regulatory requirements, because of the interactiveness or the interoperability between applications, interconnectedness of applications. An oil and gas company I was meeting with said they'd love to go to an email cloud system. However, their email system is so ingrained with their SAP system, they're not even sure how they could ever uncobble that to create a cloud-based email system. So those are the types of things that they're driving and going for from there. And when you're looking at public, and I mentioned this earlier, when you're looking at public and private, you have trade-offs. You have trade-offs relative to the benefits that you're going to receive from getting it from a public third party to the downside. The security risks, the governance risks, the customization and specialization limitations that you have for public that might be there with private. So cloud economics looks very compelling. Cloud value is going to be really faster time to value is what's driving that. And the workloads, the migrations to cloud will be workload driven, which I think is being proven out with how and why companies are moving. One of the things that we have been very much proposing, and you've seen other organizations and other industry analysts and others talking about as well, is the role that open and industry-based standards are going to be playing in cloud. Because the idea behind cloud computing is that it's going to be this combination of somebody else's resources with my resources to deliver the workload. And to do that in the best way for me as an organization, I don't want to be tied in to any one methodology. We've been down that path before, and we don't want to go down that path again. That's what CIOs have been telling us. And so, cloud standards are a key factor. Standards to address the inhibitors. In most cases, existing IT and SOA standards do apply to cloud, and so they should be reused. And recognizing that cloud standards are an emerging space. Right? You want to establish standards around virtualization, standards around your APIs and your programming models, standards around the security, standards around management, network, SLM and SLAs as it relates to your service levels of your management and your agreements, standards around storage, as well as particular industry standards that may take place and be involved. And IBM is involved in all those areas in trying to help and establish both open and industry-based standards for cloud computing. And would ask, all of you just go out and start getting involved and participate with us with this. Drive an open conversation, right? Discourage proprietary lock-in. Build a cloud ecosystem, right? That's a real key here is building a cloud ecosystem of partners. VMware is doing that. IBM is doing that, right? All of us are coming together and pulling together to try and build out an ecosystem for our customers, our businesses, to be able to leverage to their advantages and their benefits. And from an IBM perspective, we want to lead with enterprise issues. We're not looking at the consumer clouds. We're looking at the enterprise class clouds that businesses are going to want to use for their business services, and obviously engaging in industry standards. And with that, I'm going to turn over to Pratik, who's going to talk about the role service management plays in all this.
Thanks, Bruce. So all of you are associated with a data center. A lot of you have data center being run the traditional way. A lot of you have virtualization in data centers. So how do you transform your data center from where you are to where you want to be in a cloud, increasing the efficiency without sacrificing security, control, and governance? That is the challenge ahead of us. So IBM's integrated service management portfolio has the capabilities which allow you to go through that journey. Understanding where you are today, transforming to a highly virtualized environment and managing your services in that environment, and then as you pick the correct workloads to transform to a cloud delivery model, how do you go and transform your data center? So capabilities of visibility. How do you know where your services are running? As you virtualize, as you know, virtual machines can keep moving around between servers. Storage and network is shared. So how do you know if somebody told you there's a problem with the service, where is that service running? What are the components? How would you quickly go ahead and find problems? How would you understand capacity problems? Workload management in terms of how much workload can you put on a system? Problems of control. You already have processes in your data center. How do you integrate those traditional processes with the new processes necessary to manage this dynamic environment? How do you make sure security and compliance are handled? And the new problem of image sprawl. And then automation. How do you rapidly provision services, which is the cornerstone of efficient delivery models in the cloud? So the integrated service management portfolio has tools and capabilities which are directly developed for virtualized environments and cloud environments to help you through that transformation. So how do we do that? If you look at clouds, what are the inhibitors? What are some of the problems people are saying they have in moving to a cloud model? The first thing is loss of control. I don't know what's going on in that cloud. If you are an administrator, if you are a service provider, you need to be able to deliver that model and still have control over what are the changes taking place. So the best practices and the process management tool from IBM allow you to have a cloud delivery model at the same time have enough control in terms of auditing, compliance, processes to be able to deliver that efficiently. Reliability. How reliable is the cloud? When you were running a data center, you had a service level agreement. You could say, this application is up such percentage of time. So what are the concerns from a reliability perspective? And that means picking the right workloads, picking the right platforms for the workloads. Certain workloads require very high scale-up architecture. Picking, for example, a Z platform for that. Certain workloads have very high I/O requirements. Picking a Power platform or a Z platform. Some workloads are scale-out workloads, an x86 VMware environment. So picking the right platforms, working across the platform for the service. Having the right sort of SLA management tools and the monitoring tools to deliver that service are as critical. Data security. So as you put data in the cloud, how do you know nobody else is accessing it? So data loss prevention tools, tracking what's happening to the data. What is your access and identity management policy in the cloud becomes important. And if you look at compliance, regulatory compliance has to be followed for certain industries. So what are your compliance auditing tools necessary to make sure you can still certify compliance for those policies? And the compliance is not just in terms of placement and isolation, in terms of change compliance. How do you know who's changing the network settings, for example? Can you track that and audit that? Things like security management. We know in a shared environment, a compromise of a single server can result in a compromise of multiple applications running on the server. So what are the security tools necessary to make sure that you have adequate security architecture in your virtualized environment? All of these capabilities are provided by IBM's integrated security service management portfolio for your cloud and virtual environment. And we're going to go look at a little bit deeper on these capabilities. So first, where do you start? IBM built a cloud reference architecture. And this was built some time ago. And this architecture covers both infrastructure as a service, platform as a service, software as a service, as well as all the way from private cloud to public cloud to hybrid cloud. And this provides a blueprint for what are the services and capabilities you need. Now, you don't have to have all the capabilities, but it is a roadmap. You can have a starting point. I'm going to start with my data center, start with an infrastructure as a service cloud in a private cloud formation, and then I can move forward delivering greater levels of service, but the reference architecture provides you a roadmap for going forward in whichever direction. So it's a well-architected methodology of starting at a point and growing out your infrastructure. And we have used this architecture to deliver our public cloud, IBM Compute Cloud. We have used the same reference architecture for building out our internal private cloud solutions. So if you go down to the expo, you will see some of those things, and I'll take you through some of them. But essentially, it covers all the capabilities necessary to not only run a private cloud, but how do you link it to a traditional IT? You're not going to put a service desk in a cloud at the moment. You may. Some people have. But how do you link your existing cloud to your existing service desk? What is that integration? How do your lines of business get the exact information they need as they transform their application to a cloud. So the integration capabilities around the cloud you instantiated are as important as delivering the cloud, and that's what makes it operational. That's what makes it enterprise class. If you look deeper into this architecture, you have the common cloud management platform. So if you're building a private cloud or a public cloud, there are two major portions of it. The business support system, generally for public clouds or people who want to deliver their services to their clients. Things like how you do offering management and customer management pricing. If you're doing a private cloud, you probably won't need a BSS, but if you're delivering a service, you're probably going to have those. How does that integrate with the operational support system? So most administrators or IT managers are going to come across an operational support system. So it's a comprehensive system. It starts up with how are you going to advertise the services you have in a cloud, the service catalog? How are you going to link it to a request management system, which gets the right approvals, links it to the right service desk, the appropriate end-to-end management you're going to need to link it to your enterprise? How would you manage the life cycle of a service in the service automation management? It's not just sufficient to go provision a service in a cloud. Lots of automation tools can provision a service. The problem is what happens after you have provisioned a service. A user may come and say, I want to change it. I want to add some more resources to it. Is your system sufficient to be able to add more resources? They say, I want a composite application, a 3-tier application to be provisioned. Do you understand the cluster topology of the application? They want to say, okay, I want to release the resources, but I might come back later. So can you save it? Or you may say, I want to reserve this amount of cloud resources for the future. Do you have a reservation subsystem? So it is not sufficient to just provision a service. It is important to manage the complete life cycle. So the tooling understands what's called a cloud life cycle and manages the end-to-end life cycle. And that has to be linked with things like monitoring, isolation and integrity, performance management, incident management. We talk about incidents in a data center. Well, how would you tell somebody? I mean, even a dev test service is an important service for the developer and the tester. So how do you make sure you manage the traditional processes while still getting the efficiencies of a cloud? The integrated architecture handles that problem. And if you look at instantiation of an architecture, what would you start with? A simple place to start is looking at these 3 areas. A secure user-centric portal, places where users go and request services, reserve services, which is backed by some automation engine, which automates the deployment, provisioning, and deprovisioning. And that deployment is image-based. Most cloud systems are moving to virtual images. Virtual image-based provisioning is very efficient. So how do you do the image provisioning? You may choose to, in addition to the image, install some software, maybe make a data set available, make sure you have appropriate network and storage subsystems connected. And then once they're connected, how do you link it to the monitoring and the security and the metering? Who's using what? So if you look at in fundamentals the components necessary to set up a cloud, these 3 generally are critical, and that's where you start. And then you can grow out from there based on your needs. So there's an instantiation of a cloud in a product called Tivoli Service Automation Manager, and this is one of the core products which you'll see in the expo. And it's built on the Tivoli Process Automation Engine and the Process Management Platform. And that platform is common across cloud delivery and non-cloud delivery, which means you have built-in integration with existing data center tools and processes. It orchestrates people, data, and processes in your cloud environment and provides rapid provisioning of physical and virtual servers. Essentially a starting point platform for building out your private cloud, your public cloud, and link to a hybrid cloud. And actually, if you get a chance, we have a demonstration of this, not how we have built it, but how we use it internally by our IT people. So our IT team uses the same tooling to provide a cloud to our development and test environment, and the same tooling is used in the CIO office, and the same tooling is used for our public cloud. And you're going to see how our internal IT uses it to be able to deliver dev and test services to our development organization, something which a lot of people are looking at as they move to cloud. Let's look at a focus area. Let's look at security. One of the big challenges people have, or the concerns they have is, well, what about security? Am I more secure or less secure in a virtual environment? You know, if you think about it, I get different answers for different people. But if you look at the concern, everybody has security concerns. Virtual infrastructure is shared. There's a lot more dynamic. A compromise of one server can result in compromise of many applications. So IBM's complete security portfolio is specially optimized for virtual environments, whether it's identity and access, compliance and threat management, and here are some of the products. The Provincia family of tools gives you intrusion prevention services from the server to the network. A very innovative product called IBM Virtual Server Security for VMware is specifically designed for the VMware environments. It uses the VMsafe API. It provides you rootkit detection and prevention, intrusion prevention systems, privileged user auditing. It links to your enterprise-wide security and site protector. So a tool specifically designed for VMware environments, holistically managing your threat and malware for your environment. Sophisticated tool. So this is a very specific tool for this environment you may want to think about. And of course, access and identity management for your whole enterprise always work in the virtual environment. If you look at these problems we talked about, change in configuration management, patch management, security, threat management, isolation, all the industry players have really identified these problems as being key problems. And IBM portfolio covers all these issues quite substantially. Let's look at client example. ING is a large financial institution, about 110,000 employees, and they started on this transformation journey. How do we move from 13 data centers to 2? How do we transform from the old world IT to a new world IT, which is highly virtualized with a lot of applications being delivered with the cloud? And what they found using Tivoli Service Automation Manager is that they transformed their service delivery from individual software being installed to vertical stacks. Stacks of middleware, stacks of applications, which became the standard service, which they provision using Tivoli Service Automation Manager. They picked a variety of platforms, Z-Power and x86, based on the kind of service they have, based on the performance requirements. So all the platforms participated in their cloud using a single consistent interface, single consistent policy, access, identity, everything consistent. And it linked with their existing services like the directory service, like the user service, so including the service desk. So tooling which allowed a cloud environment to be instantiated in the data center, working with their existing processes, transforming the processes, working across various platforms. That's an example of how Tivoli Service Automation Manager is being used. And what they found was not only improvements in efficiency, but predictability. How many people can claim that their data center is predictable? That's a word we generally do not use. So predictability is as important because it leads to efficiencies, leads to compliance, leads to less failures. So they improve predictability in what's going on in the environment. Visibility, understanding what services are deployed where at any given point in time, how many people requests are inflow, where will they be provisioned. So improvements in efficiency are also improvements in predictability, improvements in quality, and obviously reducing cost. And transparent cross-charging ability to account for who's using what resource, which gives the IT department far greater leverage in understanding and then asking, here's the service I'm truly providing for your business. So an integrated capability which works across workloads to deliver you the efficiency necessary to transform the IT. So with that, Bruce?
Great. So, at the end of the day, there are really only three ways that an IT group can acquire the capabilities necessary to deliver IT in support of their business. I mean, when you shake everything out, all these fancy marketing words all of us companies have in talking about things, you can build it yourself by acquiring the parts and the components, sometimes acquiring services to help you design or services to help you implement. You can get it as a service from a third party, right? And getting it as a service can be something as narrowly scoped as I need help just keeping up with operating system updates across my server farm, to something as broad as a business, we don't want to be in the business of IT, so we want to outsource our IT so we can focus on running a business, right? So getting it as a service can be narrow, it can be broad. And more recently now, we're starting to see these things called pre-integrated systems and appliances, where you have hardware, software, some services already wrapped together to accomplish a particular purpose. In the case of IBM, we have the IBM Smart Analytics System that's an integration of power, storage, Informix, database, and Cognos, so that you can literally plug in, and it also has the networking configurations, plug it in, get the IP address, and any of the business users could start doing their business analytics. Or something like the WebSphere Cloudburst appliance that is literally an appliance designed to deploy rapidly and quickly WebSphere pre-configured images and packages of not only WebSphere software now, but also including Rational and some of the others. But its sole purpose is deploy images rapidly for use by developers as well as by application users as well. So you have those pre-integrated systems. Well, cloud computing can span all three, right? You can build out your own private clouds, you can get them as a service, or you can get cloud provisioned ready appliances to help deploy clouds, or cloud provision ready systems to actually deploy cloud workloads. Within IBM's portfolio, we have the pre-integrated systems. We help you build private clouds, but we also then offer a wide range of services and growing that are on the IBM cloud. We have consulting services to help. We also have implementation services and enabling technologies that are continuing being built out, like Tivoli Service Automation Manager, to help with the management of cloud and what's taking place. I wanted to kind of also talk about, and Pratik alluded to it, what IBM's doing internally within cloud. All right? We are an organization of nearly 400,000 people operating in over 100 countries around the world. As you can imagine, we have a pretty complex IT. We have research and development, both from a software as well as a hardware standpoint. We have IBM research doing all those wonderful things like working with the oil company I mentioned. So we have a pretty complex IT. So the CIO's office has been looking internally to say, how can we leverage cloud? The first place we leveraged cloud was about 7 years ago with the IBM Labs creating their own cloud. And because they were responsible for their own IT, the CIO's office said, we want to watch and see how this works. And today they now have a single cloud set up that all 7 of their labs can access at any time. They're all integrated across 3 continents, across Europe, Asia, and the US. And they, in fact, in their cloud can even go in and provision and get resources specifying what they can deal with in the areas of latency, for example, or data migration issues, so that they know, can I run the data real time, or do I need to load the data before I actually run it and design it? Or, you know what, I can't really use the resources that exist in Shanghai because of the latency issues. I need to wait and reserve time when I can get it closer to me in Poughkeepsie, where I happen to be located. So they have those abilities to do that. So it's been fun to see it grow from that to, across all of IBM, the Blue Insight, which is basically nearly 200,000 users by the end of this year accessing our client enterprise warehouse, EIW, through a cloud to do analytics on our existing customers and what's taking place. And the first 109,000 users were our sellers, and their ability to access directly through that database through a cloud-delivered service. Lotus Live, we're now at 65% of all IBMers are using Lotus Live for collaboration, for meetings, as well as for the social networking tools that it has in place. We're developing out development and test environments. The first broad company-wide development and test environment was with Tivoli, and putting that into place, where we now have all the Tivoli developers around the world accessing their resources for development and system tests through the cloud, and putting that into place. Workplace Cloud, we're at 1,200 users, and it'll be roughly around 5,000 by the end of the year, where we're taking those images from a desktop cloud standpoint that can be standardized. Because not everybody's can be standardized, but those that can be standardized where we can do it. We've identified network storage, and we've identified nearly 1,000 applications that they feel could be enabled to be end-user driven, or cloud delivered or cloud driven. CIO's office is involved with us, with customers as well, in how we're doing relative to SAP applications and how we're doing relative to different collaboration clouds. A variety of things that they're saying, hey, we think we can leverage this internally as well. So while we're out there helping our customers leverage cloud, we're also helping ourselves leverage it and really driving out costs considerably on how we're delivering IT across the business. So the keys to delivering IT as service, in addition to viewing it from the business perspective, is be workload focused. Focus on the business function workloads, not necessarily the tasks at hand within IT itself. Make sure that you're paying attention to the service management layers that Pratik mentioned and talks about. And also, take advantage of delivery choices, right? Figure out which is the most appropriate delivery choice for that workload, and what is my given budget and my given time, so what is it best? Is it something I build internally? Is it something I should acquire as a system? Or is it something that I should go ahead and get a third-party cloud to deliver this and put it into place? And time and money is usually the biggest dictating factor because the business pushes you for it and gives you very little resources to do it. So that's going to dictate which direction you go and how you go and what drives that. And then, from an IBM standpoint, we believe we can deliver for you clear economic value. We're definitely building it on integration and open standards and industry-based standards. We want it to be secure and ready for enterprise level business, and we're being recognized for that. And designing it for simplicity, right? The idea behind cloud computing is that for the end user, it's got to be easy, because it's all driven by the end user. If you go to a travel website and you can't even understand what the page is asking you to do, are you going to go back and visit it again? No. That's the whole intent behind cloud services, is you want it to make it easy for the end user, so you have to keep that in mind. And then from an IBM perspective, again, we are globally relevant, so we're there to help you no matter where your business might be located. And with that, I'd like to just open it up to any questions that anybody might have as it relates to the topic of the day here that we had. And there is a microphone. They are recording the whole session, so I hate to ask, but if you could at least walk up to the microphone, that would be great, because then that gives a chance for them to catch the question on the recording as well. Do we have any questions? Which is fine. We don't have to. Yeah, come on up.
So regarding your Tivoli Service Automation Manager, one point which you mentioned was the ability for you.
Closer to the microphone.
The ability for users to reserve resources in advance. Could you elaborate on that?
Yes, the question was, does it allow you to reserve resources for the user?
Yes.
Yes, it certainly does. So one of the more interesting aspects of TSAM is you can request a certain amount of resources starting at a particular date in the future for a particular amount of time. And as you know, if you have worked with the reservation, that's a very complex algorithm to make sure that you always have enough capacity in place to be able to meet the needs for the reserved users. So it has a very specific algorithm developed by IBM Research, which allows you to reserve resources in the future. It keeps track of the reservations in the future. So as more and more people start reserving resources, when another user comes in, the amount of resources they can reserve or request actually is shown, and they only are shown the resources available left after certain reservations would be satisfied. So yes, it completely tracks the reservations. Now, there are places, just to answer it a bit more fully, suppose there's a failure of the subsystem in the middle. And yes, what will happen then is certain users, based on your policy, so it allows you to set priority policies, can be kicked off and said, we cannot meet your reservation, but it's a catastrophic failure of the system which results in that. But most general use cases, yep, reservations are accepted. You can come and change the reservations.
Yeah, I want to make a comment real quick too about, you brought up policies. One of the key aspects that many times I should say, is overlooked relative to service management is your governance and policy side. And the whole idea behind the governance and policy side is also to make sure that it runs smoothly for the business. we had a bank that we had deployed a private development and test cloud for down in the southeast US. And basically we put it into place, loaded up, got the developers all ready to go, and said, guys, okay, we're going to come back in 2 weeks just to see how the experience. This was with one of our early deployments at TSAM. We came back in 2 weeks and asked them how that was going, and they said, we don't know. And our response is, well, okay, did you provision your images? Yep, we did that. Did you get notification, in a timely fashion that your images would be ready for you to use? Yep, we got that. So did you go use them? Well, no. Well, why not? Well, because our policy says we have to have 7 different signatures before we can use new resources for development, and we're still waiting for the signatures to come back. You got to keep up, right, with your internal policies and governance to be able to manage and handle what's taking place. When you're talking about cloud computing, you're going to have whole new sets of policies and governance that you have to put around data controls and data management. A whole new set of policies and issues that you want to put in around security when you're putting the end user in charge of making changes to the environment, for example. So it's a very important layer within that integrated service management piece is to pay attention to your governance and the policies associated with it.
That's right. And if you had the physical servers, you used to have server huggers. People who took control of servers never gave them back. With virtual machines, you have VM huggers who will take control of VMs and never give them back. What are the policies governing how you reclaim VM resources, under what conditions, how do you save off their work? So those are all some of the things you will come across, which already are coming across as you allocate VMs to people.
Any other questions? Well, thank you everybody for attending and
thank you.
Working with us.